Okay. Good day. Good day na lang. Okay. Good day. Today, what we will do is as preparation na rin siguro for you guys tackling multiple degrees of freedom, let's have a quick reintroduction or basta just an introduction to matrices. Okay? I think with matrices is that yun nga, I've discussed this in brief with you guys before, but matrices are just arrangements of numbers, right? Strategic arrangements of numbers so that we can use those numbers in different ways, right? Different ways for later, right? Matrices are just classified nga according to their size, right? According to their size. And let's say, for example, we have a matrix here with ganito lang, right? 1, 2, 3, 4. What we're going to do with this is classify this row by column, right? So that is what we'll do, row by column. There are going to be two rows in here, right? And there are going to be two columns in here. So ibig sabihin, this is what we call a 2 by 2 matrix, okay? And so ang mangyayari, each matrix, right, each number in this matrix, that is what we call an element. And let's say, for example, right, element siya, element. And let's say, for example, I want to classify for this matrix, let's say, for example, the first row, second column, gagawin natin is that we will just write down here, first row, second column. Kumbaga, yan ang ating subscript when we're talking about an element. So, right now pa lang, naka-label dito ay 1, 1, right? First row, first column. Say, for example, this guy naman will be first row, second column. Okay? And so again, just so you guys remember how we denote or how we call matrices, we will use a different font, kumbaga. And here we will use what we call blackboard bold, right? So let's say, for example, we want to name this matrix letter A. So usually we would just do it like this. But in this case, kapag nagwe-matrix tayo, we do blackboard bold. We have a different style of how we write things down para alam natin that we indeed are talking about a matrix and not just a number that is, let's say, for example, area. Iba rin yan. Okay? So, in this case, let's say, for example, we have the matrix B. Sabihin natin, we have B as 1 and 3 na lang, 3. This is what we call, because one column lang siya, this is what we call a column matrix. So this is a, ano tayo ito? One column lang siya, so something by 1 siya, 1. So in this case, this is 2 by 1. And let's say, for example, we have here column C, which is just, let's say, for example, 2, 4. This is, of course, going to be what we call a row matrix, right? So column matrix, and then we have here a row matrix. Oops, matrix. Okay. So about these matrices is that yun nga, the important thing to distinguish matrices is that even though they are collections of numbers, they can still themselves act like numbers. What do you mean? Right? In this case, we can encounter different matrix operations. Let's say, for example, let's just have matrix addition, right? Addition is possible in here, of course, so long as, right? So long as same ang size, right? Possible if same size. This is our distinction, okay? So, syempre, ang pwede natin gawin, let's say, for example, we have here matrix A. Let's say, for example, matrix A is, I don't know, just some random numbers. 3, -4, 2, right? And then let's say matrix B. Matrix B in here is -3, 4, 2, I don't know, right? Something like this. Of course, if we were to add matrix A and matrix B, because they are the same size, which is 2 by 3, right? Pareho silang 2 by 3, we can just say that A plus B, matrix A plus matrix B is just adding them together. And you add them element by element, right? So what basically happens here is that you do element A, 1, 1, plus element B, 1, 1, right? And then you proceed element A, 1, 2, plus element B, 1, 2. Kumbaga, on and on and on until you fill up everything, every entry in the matrix, right? In this case, we will have 3 minus 3, which is just 0. 5 plus 4, which is 9. 6 plus 2 is 8. 3 plus 0 is 3. Negative 4 plus 1 is negative 3. And then 2 plus 5 is 7. Right? As you can see, this is still a 2 by 3 matrix. Okay? That is what happens for addition. And now, I have to put in here, because of addition, it is now possible for us to apply the same properties that we have with addition. Namely, in this case, we can say that addition in matrices is commutative. Ibig sabihin, kahit ibahin natin ang order ng pag-add, you can still add them. You will still get the same result. Kumbaga, matrix A plus matrix B is equal to matrix B plus matrix A. Right? That is how we do it. And then let's say, for example naman, what about the zero property? Let's say, for example, is there a matrix such that A plus this certain zero matrix will still give us A? Yes, meron, right? It literally is just going to be the zero matrix. As in, the zero matrix, ang ginagawa ko is parang letter O or number 0. And literally everything is just going to be zeros. Okay? So this is possible. There is such a thing as a zero matrix. And in this case, the zero matrix can come in all sorts of different sizes. Right now, this one is another 2 by 3 matrix. Para mag-add siya via addition. Okay? So now that's the identity, right? That's the identity. And also, of course, there's going to be an inverse, right? There is such a thing that if you add it together with your original matrix, you will arrive at the identity matrix. And of course, this is going to just be the opposite of, right, the inverse, additive inverse of matrix, let's say, for example, A. In this case, you just take the additive inverse of everyone. Let's say, for example, negative 3, negative 5, negative 6, negative 3, positive 4, negative 2. And again, I'm just looking at matrix A right here. Okay? So these are the possible rules for addition. And now let's make the distinction of scalar multiplication, because there are two possible things that you can do in matrix multiplication. First is scalar multiplication. Scalar multiplication. Oh, and before I forget pala, so also there's associativity, right? Let's say, for example, we have another matrix of the same size. Hindi ko na alam kung ano, right? But let's say, for example, we have a matrix C. Ang pwede natin gawin is that we can add A and B together first and then add it to C. Or pwede nating unahin, i-add C, matrix B and matrix C, and they should still be correct. Right? They should still be the same. This is associativity. Right? Associativity. All right? And now, before we move on, before we move on to the meat talaga, the matrix multiplication, let's have scalar multiplication first. And if you guys don't remember, scalars are just what we call numbers. Sin like yung numbers lang. Kumbaga, they are not matrices. What they do, from the word itself, they scale. Right? These are numbers used to scale matrices. Right? So, very simple. Let's say, for example, hanap tayo ng bagong matrix. Let's say, for example, P. 3, 5, 2, 0, 1, 4. Right? And then, let's say, for example, our K is just 2. Right? What happens is that KP will just function how you would think it would. Right? How you think it would function. So, what you're going to do is just KP11, KP12, KP21, so on, so forth. You apply the you apply the scalar to every element of the matrix. So, 6, 10, 4, 0, 2, and 8. Right? Okay pa naman. We're still recording. Right? And that's it. That's your KP. Right? And the same thing for a lot of these, what do you call this? For a lot of these, what do you call this? For a lot of these operations, the things are the same except for, mamaya na nga yun, yung matrix multiplication. Let's say, for example, you have another one here na scalar. Let's say, for example, letter M. Letter M na lang. Letter M, which is, let's say, for example, 1/3. Sige, 1/3. Right? Of course, if you're going to do KMP, right? That's still going to be the same as MKP. Right? So, pwede rin yun na unahin mo nga muna si MP or unahin mo muna si KP. Right? That's what it means. And of course, well, the multiplicative identity here would just be 1. Right? 1 times P, which is the same thing as P. And then there's also the 0 here, which is of course 0. Na if you multiply everything by this 0 identity, by this 0 number, multiplicative 0, you will get 0. Okay? Scalar multiplication, still very intuitive. And now this is where we break for a little bit, because now we will go on into matrix multiplication. Right? For matrix multiplication to happen, you need what do you call this? Anong tawag dito? Oops. You need one requirement. Right? The first thing, or rather the first matrix, your first factor, needs to have a certain interaction with your second matrix. Right? The best way we can put this to good use would be, let's just say, for example, we have here matrix X. Let's say, for example, matrix X is 5, 3, 4, -1. Let's say, for example, that Y is going to be, ano nga ba ang Y ko? Ganyan na lang ang Y natin. Our Y will be, let's say, for example, I don't know, 0, 2, 5, 4. And let's have another one. Let's say, for example, Z. Right? Let's say Z has, I don't know, 3, 0, 0, 3. Or 5 na lang, 5. Yeah, something like that. Right? Let's say, for example, we want to take, right, X and Z. Right? X and Z, we multiply them. Okay? What will happen then? Right? What will happen then is something like this. Let's just put them together for now. Right? 3, 0, 0, 5. Ang kailangan muna natin gawin for us to ensure that they can be multiplied together is, let's take their sizes. This is a 2 by 2, and this is another 2 by 2. Oops, by 2. What needs to happen is this. The second number, or the number of columns for the first matrix, should be equal to the number of rows for the second matrix. And so, alam na natin what the resulting size will be. This will be the number of rows for the new answer, and then this will be the number of columns for the new answer. Kumbaga, what will happen in your head, or what happens usually in my head, is that I erase these two, and then what's left is the size of my new matrix. So in this case, we know that the size of this new matrix will be 2 by 2 still. Right? And what will happen now is this. Why do we care about the number of rows here? And why do we care about the number of columns in here? Because that is how we will multiply them. If you want, right? If you want the answer, let's say, for example, lakayan natin to. If you want to say, find the answer for this one, right? We need the first row and the first column. So, ang gagawin natin, kukunin natin yung first row and yung first column. And what we will do is we will multiply them in a line. Kumbaga, 5 times 3 plus 3 times 0. Kumbaga, we are putting them along in a long list, and we are taking the sum of their products. Right? So 5 times 3, that's 15. 3 times 0 is 0. So this will be 15. Let's say, for example, now we want to get this one. Right? So, this will be, ito na lang. This will be second row, second column. Right? This will be second row, second column. So, we will have to find the second row and the second column. Right? Kaya tayo naghanap ng rows lang dito is because that is the one that you need for your rows. And this one is the one you need for your columns. So what you will do here is 4 times 0 plus -1 times 5, which is going to be -5. Hopefully, if you can catch the pattern here, you can fill out the remaining ones in here. Let's say, for example, in here, your answer should be, I'll do this in my head, this answer should be 15. Right? And then, for this one naman, the answer should be 12. Right? Hopefully, you guys get. Right? And so now, yun ang ating main requirement. Yun ang ating main requirement for matrix multiplication. This kind of, what do you call this? This kind of, yung pag-check between the second number of the first matrix and the first number of the second matrix that needs to happen. And so now I will show you something a little bit different. What about z times x? Right? Ang alam natin for multiplication is that 5 times 6 is equal to 6 times 5. Right? They're both 30. But in this case, let's just look at what will happen if we multiply these things back to back. Tingnan natin kung may mag-iiba. Right? Let's say, for example, we have this. Now, let's just try this in our heads, right? Because this will still give us a 2 by 2 matrix. We know that for sure because of 2 by 2, then 2 by 2. Right? Both of these are still the same. So this will be the number of our new rows and the number of our new columns. Right? So 2 by 2 pa rin. Now, let's just try in our heads. We will have 15. Right? Now, we will have, ito na, right? 9. Right? And then, 0, 5 dapat ito, hindi 5, 0. Now, what about this? Right? What about this? We will have 20. And then, we will have -5. Okay? So, now we see that the law of commutativity, the commutative law does not exist for matrix multiplication. Just because you have A times B does not mean it will be equal to B times A. Ito ang isa sa pinaka-important na rules for matrix multiplication. Right? We have to believe that that is true because also if you think about it, what if magkaiba yung sizes? Let's say, for example, we have matrix R. Right? Let's say, for example, we have matrix R. We know that to be, 3 by 5. Right? And let's say, for example, we have matrix S. Right? For matrix S, sabihin natin, we know that that is 5 by 4. Right? In this case, we can say that R times S makes sense. Right? Because R times S will have a new size of 3 by 4. Pero, S times R does not make sense. Right? Why does it not make sense? Because now you are multiplying 5 by 4 by 3 by 5. And the 4 and the 3 are not meshing together. Oh my God. Right? And now, this is an illustration lang, a very basic illustration of why this thing does not, this thing holds, right? That the commutativity of matrix multiplication is not possible, right? Okay, so yun. Now, let's say, for example, is there a certain matrix such that if you multiply it with this, it will give you your original matrix? Yes, there is. This is what we call a unit matrix or an identity matrix, letter I. Let's say, for example, we have a letter I in here, right? Ang mangyayari is that this letter I will be almost all zeros, right? Lahat ng 0, ganyan. And then the main diagonal, which is this one, right? This one right here, will be replaced with just 1s, right? Now, let's try it out. Let's say, for example, we have y times 1. Dapat, ang goal natin is dapat same pa rin, letter y pa rin, diba? So, ang y natin is 0, 2, 5, 4. You multiply it with 1, 0, 0, 1, right? Let's try it in our heads now, right? 0, 2, 1, 0. Ready? 0. 0, 2, 0, 1. We will have 2. 5, 4, 1, 0. You will have 5. And then 5, 4, 0, 1. You will have 4. There you go, right? So that is indeed correct. That is the identity matrix, but it's only possible as a square matrix. Kumbaga, if for example you have here a 3 by 5 matrix, right? A 3 by 5 matrix, anong kailangan mong ipasok, right? Na I, such that this will still be the same. So you need a 3 by 5. You have a 3 by 5 in here, right? And then, what do you need in here? Right? What do you need in here such that ang lalabas pa rin is a 3 by 5? In this case, ang iisipin natin, okay, so kailangan 5 by 5. Right? So that these two match. And then this is the new. Right? This is the new. And this is the new. So, ganyan lang. Let's say, for example, let's just imagine a simple 3 by 5. Simple 3 by 5, let's say, I don't know, like 1, 2, 3, 4, 5, 6, 7, 8, 9. And then let's just say 0, 1, 2, 3, 4, 5. Right? This is a 3 by 5. And what you want for an I would be lahat siya 0. So, 0, 0, 0. Parang kulang ang ating size 1, 2, 3, 4, 5. Let's change this to 1. And then like this, we continue going down. Then we continue. And then down pa. And then this will be our identity matrix I. Right? And so if you're going to think about it, kayo na bahala, right? You can look at this, right? And then this. And makikita nyo, ang mamumultiply lang would be 1. Right? So, this is 1. And then, if you're going to look at this now, and then this, makikita nyo, ang mamumultiply lang would be 4. So on, so forth. Right? So on, so forth. And then, 3, 6, 9, 2, 5. Right? So, that is the power of the identity matrix. And of course, alam nyo na rin, what's going to happen in here is that if you're going to multiply it with the 0 matrix, so long as they have the size requirement that we have told from before, dapat magsi-0 matrix din siya. Right? Siyempre, si-0 nyo lang lahat. Okay? And of course, in here, kailangan square matrix din. Yung pang laban natin dito. So, instead of all this being 1, this will also be 0. Right? That is our 0 matrix. So that will be a simple introduction as to what matrix operations are. Okay? So what matrix operations are. Okay. Ano pa bang kailangan natin? Oh, inverses. Inverses. Okay. Sige, let's put in here inversion. Inverses. In this case, may makikita kayong what do you call this? May makikita kayong point in here, right? Sa addition, there is an additive inverse, right? An additive inverse is just lalagyan mo lang ng negative sign, right? If you remember that in normal numbers and just scalars, yes, that is correct. And in this case, for matrix multiplication, there's also a multiplicative inverse. But if you think about it, right? If you think about it, kapag nag-multiplicative inverse, because for normal numbers, you just take the reciprocal. So for example, if you have 5, its multiplicative inverse is 1/5, right? You just put it 1 over. In this case, let's say for example, a very simple example lang. Let's say for example, let's say you have Q na lang, Q. Yeah. Q is gonna be 2, 3, 4, 5. If you say na your Q inverse is gonna be just the reciprocal of everything, 1/2, 1/4, 1/3, 1/5, makikita mo very plainly na no, that's not going to stand. Right? Because what should happen is that Q times the inverse of Q should give you the identity matrix. So hindi. Right? Let's look at this. 2, 3, 4, 5. And then you will have 1/2, 1/3, 1/4, 1/4, 1/5. This is not going to fly simply because look at this. Without even thinking, without even looking at this, alam ko na hindi yan magsi-zero because both of them are going to be positive. Right? So, sasabihin natin, okay, maglalagay ba ako dito ng negative number? Still, no. Right? Because lahat naman sila ngayon negative. So, what's going to be our option here? What we have instead of division or matrix division would be taking the inverse of something. Right? Taking the inverse of something. Let's say, for example, we want to take the inverse of Q in here. We need it such that ang magiging goal natin is to say that Q and the inverse of Q would give you the identity matrix. Right? Let's say, for example, ganito lang mangyayari ha. 2, 3, 4, 5. Hindi natin alam kung anong itsura ni Q inverse. So, for now, I'll just say A, B, C, D. Right? Para lang malaman natin what we're up against. Right? This needs to be 1, 0, 0, 1. This will serve as our division. If ever you want na makuha, let's say for example, let's say for example, A divided by Q, there is no such thing in the matrix world. What you're gonna have to do is just get A times the inverse of Q. Right? So, tingnan lang natin anong lalabas dito. Because we have, supposedly, we have this. Ganito and ganyan. That should be 2A plus 4C is equal to 1. We have this and that. We have 2B plus 4D is equal to 0. We have this and that. We have 3A plus 5C is equal to 0. And then we have this and that, which is going to be 3B plus 5D is equal to 1. Right? So, if you can see, right, A, B, C, and D, 4 ang ating unknown. Pero 4 din ang ating equations. What you should be able to do with a lot of effort is get all of the values of A, B, C, and D. Because nga, posible naman, right? It's solvable, but it's gonna take a long time. What instead has happened in here is that they have found out, okay, there is a much easier way to find the inverse of something, right? So, for that, I will have to, I will have to share the formula for the inverse. So, hold tight lang tayo because I will just have to confirm, right? Okay. Okay. The inverse, so the inverse of a matrix here, say for example, ito, the inverse of a matrix A will be its adjoint. Kaya napasearch ako eh. It's adjoint over its determinant. So, of course, we're going to have to ask ourselves what these things are, right? And I'm hesitating here to teach you this because technically this is not my jurisdiction, right? This should be in your advanced mathematics course. But just for the sake of it, right? I will just touch over these things kasi itong adjacent na tuloy. This adjoint right here, this also has two other related concepts, which is the cofactor and then the minor. So mamaya. Let's first start off with the determinant, and even the determinant itself is a little bit wacky, sabihin na lang natin, because the determinant for 2x2 and 3x3 matrices, which is all I will give you guys, will be determined by the wicker basket method. Right? The wicker basket method is as follows. Let's say, for example, we want to get the determinant of Q. Right? The determinant of Q will be written down like this: 2, 3, 4. Ano ba? Baligtad pala. 2, 3, 4, 5. Right, nakaganyan siya. Instead of the usual brackets, square brackets, what we do is we put on parang absolute values, right? For us to find out, kumbaga, the size of this matrix, right? Kasi the determinant is, ayoko nang i-explain masyado, right? This is not very relevant to our course for now, but it gives us for 2x2 matrices the area of this matrix, and for 3x3 matrices, this gives us the volume of the matrix, right? If that sounds weird, yeah. Ito na lang, gagawin natin, we will have the wicker basket method. In this, we will have to create a wicker basket, right? In this case, what we will do is we will have to weave down and weave up, right? For weaving down, parang baligtad dapat ang gagawin ko. For weaving down, you will get a plus sign, and for weaving up, you will get a minus sign. What does this mean? Whichever numbers are caught in a weave, you will multiply. So in this case, we will have 2 times 5, and dahil you weave down, you get a plus sign. 2 times 5, that is 10. And you get a plus sign, so you retain the positive. You retain the positive. So plus 2 times 5, and then plus. We now have, right? We now have a negative sign for here, for 3 times 4, right? Negative 3 times 4. So basically what we will have here is 2 times 5 is 10, 3 times 4 is 12, 10 minus 12 is negative 2. So yun ang determinant natin. Okay? Now the joint is like this, right? The joint of Q is basically going to be, oh boy. Okay. Negative 1, right? Negative 1, I plus j, and then the cofactor of the minor, I plus j. So you're like, oh my gosh, what? Ano to? Right? And let me confirm for a little bit, huh? Yeah, I was confusing my jargon here. I'm confusing an adjoint between a cofactor. What you should do is, this is just the transpose of a cofactor matrix. So you're like, what are you talking about? Ay, ito na nga ang ginagawa natin, right? This means a transpose, and basically, hold on. Oh, hindi naman. A transpose, what you're going to do is, let's say for example, for a square matrix, hanap tayo ng square matrix. Sige, ito na lang si y. If you want to transpose y, what you will have to do is something like this. Look at its main diagonal. In this case, the main diagonal is 0 and 4. You let it stay that way. And then from there, what you will do is flip everything. Flip everything. Let's say for example, we have this 2 and this 5, they get flipped. Ganyan ang magiging transpose of y. Right? Let's now give ourselves an arbitrary 3x3 matrix. Right? 3x3 matrix. Let's say for example, ano pa bang mga hindi ko nagagamit na letter? Letter G. Yeah, letter G. Let's give ourselves letter G. 3, 4, 2, 5, 0, 1, 6, 7, 8. What you will do for the transpose of G will be something like this. You retain the main diagonal 3, 0, 6. And what you will do is now flip everything. Ganyan, you flip everything. So now, instead of this being 5 and this being 8, you will now switch them, 5 and 8. Instead of this being 2 and 4, now this will be 4 and then 2. And this being 7 and 1, this will be 1 and 7. So kumbaga, ang ginawa nga lang talaga natin is that we took this piece of origami paper and then we flipped it like this, right? Based on its main diagonal. That is what you do, right? And now, magtataka kayo, what is the cofactor now? Well, the cofactor now will be, right? Ito na yung sinasabi. Oh my goodness. Negative 1, I, and then j, and then the determinant of the minor of I and j. So you're like, oh my gosh, what is happening? What is this? Well, this has to account for the different signs that you will see, and then the determinant of m. So you might be thinking, okay, M, the minor. What is a minor in here? So, okay, let's dig deeper. Right? How do we get the minor of a certain matrix? So in a certain matrix here, what you can do is you can strip off, right? You can strip off rows and columns. Kapag tinanggalan mo siya ng rows and columns, what you will get is what we call a minor. Right? Let's say, for example, we have Q, right? We have Q being 2, 3, 4, 5. What you will do is that if you want to get the minor at 1, 2, is that you will now remove the first row and the second column. Remove the first row and then the second column. Ano matitira? It's 3, right? And I'm putting here braces because this is still a matrix, but halata naman what the size, or in this case, the determinant of M1, 2 will be, is just 3, right? It's just the size of this thing, right? And so we can continue, and ginagawa natin to, ang cofactor matrix now will do this for every single one. So kumbaga, let's now see, for example, a cofactor matrix in here, right? We will follow the numbering. Kumbaga, this again should be 1, 1. Right? So in this case, yung I and J natin that stands for the row and column numbers, in this case, 1 plus 1 is 2. You will have 1. Right? And now, the determinant of Mij. So ano ang tatanggalin natin? Tatanggalin natin ang first row and first column. Ang matitira ay 5. Right? What will happen now is that we continue. Let's say, for example, this thing. Right? Say, for example, this thing, 1, 2 na tayo ngayon. Right? 1 plus 2 is 3. So because this is negative, this is an odd number, that we will have a negative sign in here. And ang tatanggalin natin will be first row, second column. This will be 3. And let's say the pattern continues. Let's say, for example, we have here itong 2, 1. Again, 2, 1, that's an odd number. Pag pinagsama natin, that will give us a negative number. And then, ang tatanggalin natin is second row, first column. That'll be 4. And then, in here, sige, let's just have it as white. Right? 2, 2, that's an even number now, so positive. And then, what we will do is remove second row, second column. Edi, this will be 2. And now, tapos natin ang cofactor matrix natin, we will just transpose it, so we will get an adjoint. The adjoint is now this, but transposed. Negative 4 and 2. We will transpose, we will get still the same here, and now we just flip this. Negative 3, negative 4. And now, ito ang ating Q inverse. Our Q inverse, right? Our Q inverse will be adjoint over determinant. Ang determinant natin was negative 2. So what we will do is just multiply this by negative 1/2. Kasi over determinant. A determinant is just a number. It's just a scalar. And then we will just multiply it to our adjoint matrix, which is 5, negative 4, negative 3, 2. We will have negative 2.5, 2, negative 1.5, and 1. Now, to test if this really is correct, dapat kapag minultiply natin ang ating Q at ang ating Q inverse, they should result in the identity matrix. Let's try this out. 2, 3, 4, 5 times negative 2.5, 2, negative 1.5. Sorry, but ganun? Dapat ito ay positive, no? Yeah, dapat ito ay positive, and then this should be negative. 1.5 and then negative 1. Now, let's try this out. Okay. Start with the first column, first row, first column, first row, first column. And we will have, parang mali na agad, no? Yeah. Parang mali na agad. Yeah, it's, oh, never mind. Oh, yeah. 2 times negative 2.5 is negative 5. And then 4, okay, it's 6 pala. 4 times 1.5 is 6. Negative 5 plus 6, that gives you 1. Next, first row, second column. 2 times 2 is 4. Right? 4 times negative 1 is negative 4. So, 0. Let's try now second column, first row. Right? 3 times negative 2.5 is negative 7.5. 5 times 1.5 is 7.5. So, again, 0. And then finally, we have second row, second column. 3 times 2 is 6. 5 times negative 1 is negative 5. So, 6 minus 5 is indeed 1. Okay. So, mukhang tumama tayo sa ating inverse. Now, the thing about this inverse is that, well, medyo nag-hesitate nga ako ituro, number 1, because, well, hindi ko to gamay, right? And number 2, you have this on your calculator, right? If you fiddle around with your calculator, you will see that most modern calculators have matrix mode in their calculator. Let's say, for example, in the Canon that I have here at home, there is a matrix mode. In this case, it's number 7. If you go mode 7 in your Canon, kung sa inyo medyo nagka-class-wise ata kayo eh. Right? But this one is apparently good for board exams. I don't know what regulations have changed now. But what you can do with matrix mode is that you can give your calculator certain matrices. And for Canon, umaabot siya ng 4x4. It can go from 1x1 to 4x4. So any combination of those will be good enough. I think ang ginagawa nila is, yeah, just this. For class quiz, I don't know if ang abot siya ng 4x4 or hanggang 3x3 lang. But in this case, you can give your calculator these matrices. In here, it can store up to 4. So matrix A up to D. And ang pwede nyo gawin is that you can make it perform different calculations for you immediately para hindi na kayong gagawa ng ganitong klaseng bagay. You can let the calculator do its thing. Right? Very handy ang kanyang pagkuha ng inverse. Right? The inverse of, let's say for example, A, para diretso meron ka ng inverse agad-agad. You don't even need to know the value of the inverse, although siguro baka magbigay ako. Right? Ang gagawin nyo sa calculator is, so let's say for example, math A, right, times the inverse of math A. Ang lalabas dapat dyan would be your identity matrix. Right? Your identity matrix. Okay? Yun lang naman. Kaya hindi ko masyadong dapat ituro itong inverses. Right? And we are going beside the point. The point is, tinuturo ko ito lahat sa inyo because we want to be able to solve multiple degrees of freedom, right? In a more systematic, in a more efficient way, right? Let's say, for example, we have something like this. Let's say, for example, we want to know that if, for example, we have here two different systems, and let's say, for example, ito, we have x dot and y dot. These are just two different, what do you call this? Differential equations. Right? Let's say, for example, it depends like this. 4y and then 3x minus 2y. You can see that the movement or the velocity of x and y both depend on x and y as well. And in this case, pwede natin siyang gawin na matrix form. What you can see here is, right, we can turn this into 5, 4, 3, negative 2 of x and y, and we can turn that x and y into x dot and y dot. Right? Hopefully, you guys can confirm this if you doubt this transformation, but you can confirm this, right? And what basically happens here is that we can do something like this. We can treat this thing as a kind of coefficient matrix. Gagawin ko na lang for ease of reference, let's just call this matrix A. And look at this. These are variable matrices. And what you can see pa is that this is going to be x. And if you just take the derivatives, time derivatives of both of these components, what you will get is x dot. Right? So now you'll see this equivalence in here na x dot is equal to ax. Makikita nyo, wait a second, I know how to solve this. Kunyari, kapag pinasolve sa atin na dx, right, dx over dt, of, I don't know, 5x. What you will do is just make it variable separable, or kayo nga bahala, honestly. Dx over x is equal to 5 dt. What you will see is that if you integrate, you will get ln of x. And then this is now 5t. What you will see is that you know your answer immediately. CE 5t. Right? Plus C pala tama. Right? This is now your answer. As you can see here, you can use variable separable, or what you can do is use the differential operator. In this case, this is just this. And now what you can do is that if you use the differential operator, you get dx is equal to 5x. Now you can throw away the x. You will see d equals 5. And you will see the same thing. Alam ko na yung sagot ko for x. X is just CE raised to 5t. Kasi your d is equal to 5. And now in this case, we can do the same thing with x is equal to ax. What you can do, right? What you can do is guess that your answer will be x is equal to some coefficient, right? Some constant in here. Let's say, for example, k. Minsan nga, c na lang. Sige, c na lang. E, and then some number t. Right? Kasi all of this is still related to time, right? And now, if you look at this, okay, you're thinking, pwede. Pwede siyang sagot. And now, if you derive, right, with respect to time, syempre, what do you think will happen? Chain rule. Ibababa natin si omega, c, e, omega t. Now, let's try and put this back together in here. Right? Let's put this back together. We will have omega c, e, omega t is equal to, right, a times c, e, omega t. What do you guys notice? Cancel, 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 cancel. You will have a kind of a weird equivalence. You'll have a number or a scalar be equal to a matrix. Nagkamali ba tayo somewhere? Certainly not, right? Ganito naman talaga mag-convert or rather mag-derive. What instead is being done in the background here is what we call eigenvalue. Right? This scalar here is an eigenvalue. Eigen is from the cognate for German eigen. Literally eigen. Ibig sabihin nito is sarili. Its own. In fact, these two words, or rather this prefix right here, yung sa German na eigen, and our English word own, they come from the same parang word. Right? That's why they kind of sound the same as well. So, ibig sabihin, an eigenvalue is something you can get from a matrix. Right? It's something you can get from a matrix to get its number. Right? It's not its number per se, pero you can get a number or a scalar out of a matrix. Right? So, in this case, magtataka ka, how does this happen? Right? How does a matrix, a collection of numbers, equal one number? Well, we're hiding some of the things in here, right? We're hiding some of the things in here. Let's say, for example, hindi nga A, kasi nalagyan ko na to ng A. Let's say, for example, sige, B na lang. How can B be equal to a number? How can B be equal to an eigenvalue? An eigenvalue is usually stored or denoted as the Greek letter lambda. Kasi magtataka kayo, syempre, this is not true. Because there is a hidden identity matrix in here. And so if ilipat natin sa kabila, we will have B minus lambda I is equal to 0. Or in this case, because we are talking about matrices, let's talk about the zero matrix. Alright? So in this case, ang eigenvalue natin daw should be attached to your what do you call this? To your identity matrix, and if you perform B minus the eigenvalue times your identity matrix, it will give you 0. So in this case, paano natin malalaman itong equivalence na ito? Well, we're going to have to get the determinant. The determinant of this thing, right? The determinant of this thing should be equal to the determinant of the zero matrix. Ano pa ba ang determinant ng zero matrix? Well, it's just zeros all around. This should just be 0. Okay? And so let's try to find the eigenvalues, right? The eigenvalues of your A now. So ang A natin ngayon currently is 5, 4, 3, negative 2. 5, 4, 3, negative 2. And in this case, what we will have to do is just get the determinant of A minus lambda I. Right? Okay, try natin. A minus lambda I will be equal to 5, 4, 3, negative 2 minus lambda, kung ano man yan, times the identity matrix. Identity matrix, this is a 2 by 2. So, oops, ganyan. Right? And now we will see, so this will be 5 minus lambda. Ito remains the same. 3 and then negative 2 minus lambda. Okay? And so now, we get the determinant of this, and this should be equal to 0. And what are we supposed to do? Right? The determinant of this, we can just get through the wicker basket method. Right? We can get through the wicker basket method. Okay. Let's say, for example, ganyan na nga, wicker basket, pagpababa, may positive sign. So, right, positive 5 minus lambda times negative 2 minus lambda. And then minus, right, 3 times 4, which is 12. This should be equal to 0. So let's just put everything together. Let's expand. Negative 10, 2 minus 5, negative 3. And then we have this minus 12 is equal to 0. Tama ba? Negative 10, negative 5 lambda, positive 2 lambda. Yes, that is what we'll have. And now, let's just rearrange this. Lambda squared minus 3 lambda minus 22 is equal to 0. There are going to be two values of this lambda. So, let's just put this through our, anong tawag ito? Through our, anong tawag dito ulit? Through our, I'm so sorry, I'm forgetting the, ano here, the name here. Quadratic formula. For quadratic formula, 9 minus 4ac, so plus 4 times 22. So this is going to be a complicated number. So let's just see this. Actually, ipasolve na lang natin kay Desmos. Actually, meron pala dito. X squared minus 3x minus 22. So we'll have two different numbers. This, negative 3.424, negative 3.424, and then positive 6.424. So these are our two eigenvalues. Right? Now, pag may eigenvalue, meron silang katapat na eigenvector. Okay? Meron silang katapat na eigenvector. What we will do with that will happen later, but for now, ito yung magiging itsura ng mga sagot natin. Right? So now we finally find out that okay, yun pala dapat ang ilalagay natin dito. But now, you're going to say to yourself, okay, this is two values. Right? Merong isa na negative 3.424, may isang 6.424. And actually, that is what we're going to do. The guess here, or rather the answer, will involve two answers, one for x and one for y. Kumbaga, if we're thinking about it that way. And in this case ngayon, what will happen is that we're supposed to have these things right here. C11, C11, C21, C12, C22. Right? And then, maglalagay tayo dito ng e raised to, right? Ng e raised to, ano yun? Negative 3.424 time, and then maglalagay tayo ng e 6.424 time. Might be wondering, nasaan na yung mga constants? Kasi hindi pa naman tayo makakakuha ng particular solution in here because, well, wala akong binigay na boundary conditions. You would be correct. So in this case, we would just put our constants here. A and then B. So as you can see, ang kulang na lang natin is this one, the coefficient matrix. Where will we get the coefficient matrix for this? Well, actually, you can think about it like this. We will have two different matrices for this. We will have two different column matrices for this, and they correspond to the values of the eigenvector for lambda 1 and the eigenvector for lambda 2. And kailangan order matters in here. Ha? Kailangan order matters because this one is responsible, or rather, this is the first eigenvalue, and then this one is the second eigenvalue. So kailangan order matters. If you're going to switch them, switch these as well. Okay? And so how are we going to get the eigenvalue, the eigenvectors for the particular eigenvalues in here? Well, what we're going to do is isasaksak natin siya pabalik dito. Okay? Sasaksak natin siya pabalik dyan. So, let's say for example, we have our eigenvalue na una will be negative 3.424. So what we will do is we will put them back into our original matrix. Yung A minus lambda I, right, will be 5 minus plus 3.424 and then 4. And then 3 times negative 2 plus 3.424. If we're going to put this together, we will have 8.424 and then 4, and then we will have 3 times negative 2 plus 1.424. What you will see between these, hindi pa halata masyado, right? But if you're going to do this, 8.424 divided by 4, you'll have 2.106. If you're gonna have 3 divided by 1.424, you will have 2.1067. So if we put these together, kumbaga, if we're going to if we're going to make them stick, kumbaga, we can see the values of these two, or rather the ratio between these two, are the same. Right? Kumbaga, this you need to multiply by 2.1067. Oops. Multiply by 2.1067 to become this. You need to multiply this by 2.1067 to become 3. So that is the thing that we want to, kumbaga, consider now. Usually, how you would put this together is you would imagine in here an x and a y, and then ang gagawin mo is dapat magzi-zero. Ito. Right? So now let's try and think about this. 8.424x, right, plus 4y is equal to 0. And so now, try and think about this. Ang ginawa nga natin earlier is that we divided this by 4. Ang lumabas is that this is now 2.1067x x plus y is equal to 0. And now, if I'm going to move this to the other side, your y is equal to negative 2.106x. Palitan natin ito. Yeah. What do I do with this? Right? Ang gagawin ko na ngayon is that now I will think, okay, if I substitute x is a really simple number, if x is equal to 1, ano magiging value ng ating y? It would be negative 2.106. Or, honestly, pwede rin naman negative 1 ito. Ito naman ay magiging positive 2.106. So, honestly, you guys pick. This will be my column vector. This will be my column vector negative 1, 2.106. That is how we compute for a column vector. Now, alam ko na yung mga value ng C11 and C21. Next, we go with our second eigenvalue, which is now yung 6.424. Second eigenvalue, 6.424, will be, or will have pala rather, ano nga ba ulit yung original matrix? 5, 4, 3, negative 2. 5 minus 6.424. 4, diba? Tama ba? Yes, 4. 3, negative 2 minus 6.424. So if we put this together, we will have 5 minus 6.424. Nga pala, right. Negative 1.424. 4, and then 3, and then negative 8.424. And now you will see again, medyo garbage pa yung itsura ng ating hindi ba simplified, kumbaga. So if we're going to simplify things, we will have 4 divided by 1.424. This will be, 4 divided by 1.424. This will be 2.809 na lang. 2.809. So what you will need to do is you will need to multiply this by negative 2.809 for you to get to 4. And let's see, for example, 3 times 2.809, 8.427. Pwede na rin. Sige, pwede na yan. If you multiply this by 2.809, you will get kind of the same answer. So again, we can imagine here x and y, and then we can imagine here 0 and 0. So ang gagawin na natin again is negative 1.424 times x plus 4y is equal to 0. And then let's divide everything by, let's divide everything by 2.809 yung ginagawa natin. Negative 2.809. You will get x minus, right? X minus, hindi pala, 2.809 tuloy. 1.424. X minus 2.809 is the thing here. Y is equal to 0. Lipat natin sa kabila. You will have x is equal to, x is equal to 2.809y. So now, in this case, if your y is equal to 1, di madali lang yung x. Yung x natin will be 2.809. So that will be our second column vector, right? It'll be 2.809 and then 1. Yan ang ating sagot. Okay? And so now you can put all of this together such that your answer will now be, try natin yung C1, or rather the column vector for eigenvalue 1 will be negative 1, 2.106. For the second eigenvector, that will be 2.809 times 1. And now, if we put all of this together, you can get this answer, which is not very accurate, by the way, pero it still gets the job done. Now, our answer here, you can just read as x, right? If you remember what is x in here, that should be x and y. Now, we have completely demystified or decoupled yung relationship ng x at ng y. Ang ginawa lang natin is that we are now going to turn our values of x and y all in terms of time, right? X is going to be equal to this one, right? And then, yung y natin is like this, right? So, this will be x is equal to negative a e negative 3.424t plus 2.809b e raised to 6.424t. Yung y naman natin ngayon will be 2.106a e raised to negative 3.424t plus b e raised to 6.424t. That is our answer without much playing around with differential equations. If anything, the only time na humawak tayo ng differential equations would be this, right? And this is supposed to be no issue because nagkaroon tayo ng shortcut, which is the differential operator. That is why we found out the guess so easily. Parang, I've seen this before. This just has to have a value that is equal to the eigenvalue of A. And from there, we've gotten our solution. So honestly, in this case, you guys can choose to put this together if hindi kayo naniniwala, right? What you can do is substitute 5 times the value of x in here, but 4 times the value of y in here. You can also choose to just multiply or derive both of these things, right? With respect to time, dapat ang lalabas is this kind of property. And the thing about this is that nanghula lang ako ng values ng 5, 3, 4, -2. Kaya lumabas medyo yucky ang ating mga values. Right? But ganun talaga eh. Ganun talaga. Right? Especially from here. This is where things got a bit messy. Right? Ayun. Yun lang naman. That is how you're supposed to do this. And mind you, this is multiple degrees of freedom, but this is first order. Right? What about second order? Okay? Now, okay, magwa 1 hour pa lang naman tayo. Let's try and explore second order. And now, I'm gonna have to pull up a nicer set of numbers para hindi naman tayo sobrang gigil sa decimals. Okay? I'll be back. Let's see. Okay, I've found a better looking set of numbers in here. Now we'll try looking at this on a perspective of 2 DOF, right? 2 DOF. Let's say, for example, we have this system right here. We've managed to somehow get these guys in order such that x double dot is equal to -5x plus 2y. And then for y double dot, you will have 2x minus 2y. So now we will have something like this. And of course, we can turn this into, we can turn this into a simpler, right? A simpler kind. We can just turn this into x double dot, y double dot as a matrix in here is equal to, right? -5, 2, 2, -2, and then x and y in here. And again, we can see that this just looks like x double dot, right? X double dot as a matrix, of course. And now this is going to be, again, I'm a bit tired of A. Let's turn this into K na lang K. K. And then this is just your original version of your X matrix. And so as you can see here again, if I were to give you guys a very easy version, let's say for example, Z double dot is equal to 5Z. What you can just do is just, I can use the differential operator, turn this into D squared Z is equal to 5Z. And you can throw away the Z's, you can get D squared is equal to 5. Right? And what you can do is you can arrive at the answers D is equal to plus minus square root of 5. Right? And you can say to me, okay, I know the answer to this is going to be Z is equal to AE, right? Positive square root of 5t plus BE negative square root of 5t. And so what we will do is the same here, right? What we will do is the same here, but now there are a few more hoops to go through, right? Your guess is now going to be still the same, actually, honestly, right? X is going to be equal to C E omega t, right? We have to know what that value of omega is going to be, and let's just derive it twice. You will arrive at, of course, if you're going to derive this twice, you will have to bring down the omega twice. You'll get omega squared CE omega t. And so if we're going to put everything together in here, what you will see is omega squared CE omega t is equal to, right? Is equal to K C E omega t. And so again, we can cancel, and now an extra bit in here. What you will need to do is square root, right? And so now if we can turn our if we can turn our matrix into just a number, it would be the eigenvalue. So in this case, the eigenvalue of this matrix, you're gonna have to square root that for that to become the coefficient, or rather the root of your answer. Okay? So that's something we have to keep in mind, and therefore we can proceed with what we're supposed to do. Right? We need to find the eigenvalues of K, so we can immediately go to determinant of the matrix K minus lambda I. Right? Hopefully, you guys can follow along that. If we're going to do that same operation, we'll just add minus lambda to the main diagonal because that is what doing lambda times identity matrix will that's what it'll do, right? When you multiply them together and then you subtract that from the original matrix K. 2 and then negative 2 times lambda. And again, wicker basket method, right? This one plus, this one minus. Okay. So now we will have negative 5 minus lambda times negative 2 minus lambda. You will see that all of them have negative values. Eh di, magpa-positive sila lahat. Minus 2 times 2 is 4 is equal to 0. You'll now have just 5 plus lambda, 2 plus lambda, minus 4. The promise here is that this is going to give us a cleaner set of lambda values. Let's try now 10 plus 7 lambda plus lambda squared minus... Okay, it will give us cleaner values. It will give us lambda squared plus 7 lambda plus 6. Yan. And so now you guys can hopefully see either through the quadratic formula or via factoring that this is going to be lambda plus 6 and then lambda plus 1 is equal to 0. So you will have two different values pero medyo nakakatakot na because the two values are negative. Kung negative yan, what are we going to do here? We're going to get the square root of a negative number, but in this case, we are no stranger to doing the square roots of negative numbers. Alam natin na may I na lalabas, and ibig sabihin, pag may I na lumabas dito, we are gonna have to turn them into sines and cosines for later. Right? So alam na natin yun. Okay. So ibig sabihin pala, ang magiging sagot natin dito is CE square root lambda T. And so now, let's put our guess in here somewhere. Dito na lang. Ang ating guess for X will be, right? Ito will involve, right? The values for our column matrices from our eigenvectors. This is for eigenvalue 1. This is for eigenvalue 2. And then we will have in here, right? Anong tayo dito? E raised to negative. Ang una nating eigenvalue is negative 6. So square root of negative 6t. Alam na natin what that sounds like. That sounds like cosine square root of 6t plus sine square root of 6t. Right? And because we are dealing with a double, second order differential equation, we will be able to give you, right? The matrix is able to give you two, the differential equation should be able to give you two, right? Constants. And the same goes kapag dito naman, right? E raised to square root of negative 1t. Ang ibig sabihin nun will just be cosine of t and then sine of t. And again, right? Dalawa ang pwede natin mabigay na constant. And so now what is left is just these two. Okay? So we'll find them now. For our eigenvalue of negative 6, pupunta tayo sa original natin. We will have negative 5 minus negative 6 is 1, 2, 2, and then negative 2 minus negative 6, that is 4. And so now, okay, mas madali. Mas nakikita nyo na you just have to multiply by 2 to get the 2. You just have to multiply by 2 to get the 4. So, kayo na bahala, right? I'll just take this one, right? This will be x, right? Plus, hopefully nakikita nyo na rin, right? X plus 2y is equal to 0. And now, lipat natin si y sa kabila. Negative 2y. If, right? If your y is equal to, I don't know, 1, your x is going to be, equal to negative 2. Pwede nyo rin naman baliktarin, negative 1. This will be positive 2. So, yan, pwede na yan. 2, negative 1. I won't be giving like minuses if ever you do negative 2 and 1. That's the same. Right? That's the same. 2, negative 1. Now, for your eigenvalue of negative 1, we will have, limit ko na naman. Negative 5 minus negative 1 is negative 4. 2, negative 2 minus negative 1 is negative 1. So makikita nyo and here that you just have to multiply this by negative 2, right? And then you just have to multiply this by the same amount, right? So ganon, either way, you can just choose negative 4x plus 2y is equal to 0. Lipat ko to sa kabila, we will have 2y is equal to 4x. And then basically just y is equal to 2x. Right? If your x is equal to 1, right? If your x is equal to 1, then your y should be equal to 2. And that is immediately it. 1, 2. Now we combine everything. Right? Your x value will now be, ano ulit yung, well, nakakalimutan ko, 2, negative 1. And now here's 1, 2. And we can write down everything now. Cos 60 plus b sine 60. This now is c cos t plus d sine t. Right? And so, right, how are we going to rewrite this in terms of our x and y? Kasi yun naman talaga yung kailangan natin, right? We can just matrix multiply. This one, and then this one. Kumbaga, 2 times everything. 2 times this, and then 1 times this. Okay? So we will have 2a cos 60, square root of 60, plus 2b sine square root 60, plus c cos t, plus d sine t. For the other one, for y naman, di this, right? And this, aka this times this, and then this times this. Okay? So let's write that down. Negative a cosine squared of 60 minus b sine squared of 60 plus 2c cosine t plus 2d sine t. This is our answer that will satisfy this condition. Right? So, ganun ang gagawin natin. If you guys would like to check it out talaga, then go. Right? Kaya nyo yan. But this will be the answer for x and y that will satisfy the condition x double dot is equal to negative 5x plus 2y and y double dot is equal to 2x minus 2y. Okay? So as you can see, meron tayong general flow. Right? You have to connect it to what you know, aka this first step right here. Right? Connect it to this first step you know. Apply, right, the matrix the matrix equivalent because you are not sure, right, how to turn a number to matrix. Edi gawin nyo na eigenvalue. And therefore, from there, you apply the matrix connection. Hanapin nyo yung eigenvalue. And from the eigenvalue, you get the eigenvectors. And now, you rewrite everything for the final answer. Okay? That is what's supposed to happen. Okay? That is what's supposed to happen. So, actually nga, you guys can try out different values for this just to practice yourselves, right? Just to practice yourselves. And minsan, what will happen is that this will not be this easy. Right? What will happen usually is that we will have, right, another matrix in here. Because if you guys remember, right? If you guys remember, ang totoo talaga dito is going to be MA, or rather MX double dot plus KX is equal to 0. Right? So in this case, ang dapat pala, tatanggal mo muna itong si M matrix. And how do we do that? Normally, what we would do is we would divide by M. Pero hindi nga yan possible. So what you're supposed to do is M times M inverse. Right? M times, M times M inverse. So ito, yung times mo rin ng M inverse. So that is how you get your answer. Okay? So yan. Please do let me know if you guys have any questions here. Ayun nga, I am a bit dismayed na ito pa talaga very important ito for your final coverage, right? For the final coverage. Ayun lang, if you do have questions, please do let me know. Some of you are reaching me already through Facebook. Some of you are already reaching me through Canvas or email. Okay lang naman. Just please, right? Please ask questions if ever you are not clear about anything. Okay? Thank you, guys.